Hey, this is Sam from Cordova Woodworking. This is part one of a two-part tutorial series on how to make this minimal side table. These two videos cover everything from start to finish on how to make this piece. We go through milling, material breakdown, cutting joinery on a table saw, assembly, and of course sanding and finishing. Woodworking plans are available for this piece. Just check out the description below. And I'll note that this video does cover a pretty big range of woodworking techniques that can help you build this table successfully. That said, if you do decide to build this piece, you should get professional in-person training to ensure safe execution for all your woodworking operations. Good luck and be safe.
So the first thing I like to do in any simple project like a small coffee table or a side table is to break down my rough cut lumber into more manageable sizes. From there, I'll move on to the milling and squaring of each component blank down to its final dimension. You can refer to the project plans for the exact dimensions each blank should be for each component. One thing that you should note when you do your rough board breakdown is that it's nice to have a little bit of material left over on the side in case you have any defects, especially when you're working with a project that requires traditional joinery. It requires a lot of precision, and it's likely we're going to run into mistakes. And when you go to your material supplier, don't try and get an exact yield, because the last thing you want to do in the middle of a project is run into the worst bottleneck possible of going back to the lumberyard. One thing I like to do when I break down the rough cut boards is label each part, because they can all look kind of similar sometimes, and when you move over to the jointer and planer, you want to make sure you're going to be milling and cutting down each of these parts correctly, and you're not making duplicates or cutting the wrong piece. This happens, and it's just a good thing to avoid by doing some simple labeling. So here we've got the rough cut lumber that I've already broken down to more manageable sizes before milling. This is going to be the top, and then we've got the rails and 4 legs, and then finally the 2 stretchers that run front to back. I like to do all my milling for each component, especially for the base, at the same time. It's nice to be able to mill and square all of your parts to final dimension, bring them to your workbench, and then understand from there exactly how to proceed.
The first stage in milling any piece of wood is to flatten one side of the board on the jointer. First, always check your joiner for square. In general, most boards have some curve to them. When choosing which side to flatten first, flip your board on your jointer until you notice the curve is pointing towards the ceiling. When bringing your boards over to your planer, make sure they're all oriented in the same direction. Ideally, the milled or flattened surfaces should be facing down so there's no confusion. Bring all of your boards down to correct thickness, and then you'll be ready to joint the first edge of your boards before ripping them on the table saw. I'm going to reiterate the milling procedure more than once throughout this course because it's fundamental to good woodworking. When we mill our workpieces properly, it makes everything so much easier and elevates the quality of our work. When using the planer, always check your workpiece for your desired thickness and double check each piece for square. Now that you've made 2 faces flat and parallel with each other on each workpiece, joint one of the rough edges on the jointer. After this, you will rip each of the workpieces to final width on the table saw. Refer to the dimension drawings for the correct widths each workpiece should be.
Cut each component down to size, I like to use a crosscut sled. I just find that chop saws are often inaccurate, and I want to make sure each component is identically sized, so I'll use a stop, and I'll make sure my blade is perfectly square. So at the end, I have a perfectly milled, squared, sized blank. Take your time and be methodical through this process to make sure that you're cutting each component the right length. Mistakes do happen, some of the components are similar in size, and you want to make sure that each component is cut to your intended length.
It's a great practice to always check your table saw blade for square. To be as efficient as possible, I secure my table legs to the crosscut sled and do the first pass all in one cut.
You're going to want to set up a stop, and if it's on the fence, definitely make sure it's an auxiliary stop so your workpiece can exit freely from the fence.
This will be the final length of each of these parts, so double check with a tape measure between the table saw blade and your auxiliary stop that you have the desired lengths. To cut the length of the stretchers, follow the same procedure, except attach the stop to your crosscut sled.
It's critical at this stage to make sure each component is sized perfectly and also perfectly square, because it's going to make each stage moving forward a whole lot more straightforward and simple. So after spending some time at the joinery, planer, and table saw, we've got our final dimensions of our component blanks. We've got 2 stretchers and 4 legs. The rail is actually not at final length yet. The reason being is I want to, once we make the half lap joints into the stretchers, we're going to mill the rail down so it is piston fit in those stretchers, which I'll show you in a later stage. And of course, we've still got the tabletop board. We're gonna mill, cut, size that another day. So now that our blanks are cut to size, we're gonna cut the angles on our legs and our rails. Now, as you can see on this leg, I've marked out exactly where the angle needs to be. It's just parallel on each end. And it's just a reminder so I don't make a mistake or cut the angles not at parallel. When you're doing multiple components, mistakes like that can happen pretty easily, and you don't want to have to go backwards in the project.
Try to be as precise as possible when setting your table saw blade to the desired angle, as you do want it to match your tenoning jig.
Cutting the angles on the legs is a super simple operation. You're going to want to use the crosscut sled. You're going to want to set up a stop, and if it's on the fence, definitely make sure it's an auxiliary stop so your workpiece can exit freely from the fence. Set your blade to 4 degrees. One thing I like to do is I like to orient, even though I've already marked out exactly how I want all my angles to be, it's a good practice to orient all your workpieces exactly the same so you can move through the operation fluidly, and then it further mitigates the chance of making an incorrect cut.
When making these cuts, be careful not to remove too much material from each end of the legs, as you don't want your table to be shorter than the desired height. That said, it's not absolutely critical. Your table leg height is identical to the dimension drawings.
Now, using the same saw, just flip your workpieces and go through the same operation.
Do a quick check to be certain all of your angles are cut on the correct plane.
The operation for the stretchers is similar. We want to cut 4-degree angles, however, they are not parallel.
I cut both stretchers at the same time just because I like little efficiencies like this, and be sure you use a stop thick enough to make sure both workpieces are held properly in place.
So now that we've cut the angles, we're going to remove the material and the stretchers that's going to create the floating effect underneath the tabletop. To do this operation, you're going to use a drill press or a drill. as well as a 90-degree tenoning jig, which I've included plans for in this package. You're gonna wanna clamp them together like this, so they're mirroring each other. And from there, take a look at the plans to see exactly where you need to drill your holes and mark them out like so.
Make sure to clamp your workpiece down and drill exactly on the seam line between the two workpieces.
So now that the holes have been drilled in the stretchers, we're going to remove the last bit of material before cutting the joinery on the stretchers. And you can see that I've marked it out right here. We'll do that with the 90-degree tenoning jig on the table saw. What you're looking for in this operation is that the top of the table saw blade will come in tangent with the bottom of the drilled hole, and also that the depth of cut is tangent with the bottom of the drilled hole. So what's critical in this operation is that the table saw blade's height reaches the bottom of the drilled hole and no further, as well as having the depth of cut reach the bottom of the drilled hole as well. And to get it perfect, don't try it on the first time by lining up with your lines, with your marked lines. Just sneak up on the cut on your first one, making multiple passes until it's perfect. And then from there, you can move through the rest more fluidly. So this is what your stretchers should look like now. So now that the angles have been cut and the stretchers have been brought closer to their final form, we're ready to move on to the more challenging but rewarding part of the project, which is the joinery. We're going to do this on the table saw with a angled tenoning jig. And it's part of the project you want to be as patient and methodical as possible, as it is quite challenging and requires a lot of precision, but you can get great results as long as your tenoning jig is made perfectly square and it's stable and of course safe. Here's an example of what the result can look like. Piston fit and secure, so it's an angled bridle joint, and yeah, you can get quality results if you're methodical and patient. The order of operation is to cut the female part first of the bridle joint, being this, and then cut the male part, the tenon. The reason being is that once this is cut to size, you can cut the tenon over size and then sneak up on it until it's a perfect fit, like this test right here. To get great results, you're definitely going to want to do a test run on some scrap material. In an ideal world, your test will be done on a piece of material that is the same dimensions as what you plan to work on. Absolutely make sure that you do your best to get the mortise centered on your workpiece. And then you're going to want to make sure all your mortises are identical. And to do that, we're going to do it on the table saw in multiple passes. However, we're going to cut the outer extremities, the left and right side of the mortise, all in sequence. So we'll do the left side all in sequence for each piece, and then we'll do the right side all in sequence for each piece. You can see here I've already marked out where my mortise will be centered, and I'll probably just try to get it exactly inside those lines since I know they're fairly accurate. Though the dimension drawings say it needs to be 0.5 inches wide, it's unlikely we'll get that to be absolutely perfect, We'll try our best, but what is important is that it's centered, and then once it's as close to 0.5 inches wide as possible, we'll make sure the tenon fits perfectly into the joint on the leg. Another important thing to note is that in the dimension drawings, it says that the mortise is exactly 1.25 inches deep. However, it's unlikely I got this part of the stretcher to be exactly 1.25 inches. So the depth is actually going to be what we really cut. So make sure to double check that measurement.
I'm setting up the blade height to cut the bridle joint. Just be sure to match it to the height of the tenon on the stretcher and you'll be looking good.
Now remember, we're going to make this cut 4 times in a row, 1 on each leg, so the mortise is identical on each leg.
Continue to repeat the cuts on each leg. Be sure to turn off your table saw between cuts and that your workpiece is attached securely to the jig.
So now all of your parts will look like this. We've cut one side of the mortise, and you're going to cut the other side all in sequence, just as I demonstrated. And then from there, you can hog out the middle to create your finished mortise.
I moved my fence over to cut the other side of the joint. Be sure to keep the blade inside the marked lines made on your workpiece. It's critical to be precise here to ensure the mortise is centered.
So we've got identical mortise widths. Now, operation's pretty simple. It doesn't require as much precision. We just need to cut and hog out the rest of the material in between those lines.
Now it's time to cut the tenon. Like we did before, we're setting the height of the blade referenced off the tenon's counterpart, in this case the leg. Set the blade height to be slightly higher than the thickness of the leg. We want it slightly higher so there's a bit of protrusion on the tenon. You can easily sand this down or cut it flush with a pull saw. If there's any part of the project that you need to focus and take your time on, this is it. It's very important our joints are cut precisely. Make sure to slightly oversize your tenons on your first cuts. We will sneak up on a perfect fit after we've removed most of the material. I recommend attempting a perfect fitting tenon on a practice piece of material before cutting your actual work pieces. After making the first 2 passes on each stretcher, adjust your fence over to cut the other side of the tenon. Be sure the blade is on the outside of your marked lines. This is what the tenon should look like. Now it's time to remove the material on the left and right side of the tenon using the same procedure. Once that's done, we'll sneak up on a perfect fit by shaving equal amounts of material off both sides of the tenon. It's important to remove equal amounts of material off both sides of the tenon so the tenon remains centered. Now it's time to sneak up on a perfect fit. Shave as little as possible off each side of the tenon to get a perfect fitting joint. Test your fit after each pass. So this is obviously a very challenging part of the project. Everything can be made a whole lot easier and less stressful if you do a practice run using scrap material.
Now that the bridle joints have been cut for where the legs meet the stretchers, we're going to cut the half lap joint where the stretchers meet the rails. We're going to use the cross-cut sled on the table saw. A key here is to make sure that your blade is perfectly square and then you get the depths of cut exactly where you want them. Another critical point here is you're going to start with the joinery on the stretchers and not the rails. And the reason for that is we need to get the rails to fit into these cuts perfectly. So we'll undersize them just slightly and then we'll do a little plane, a really shallow plane on the rails and sneak up on a perfect fit. So I'm using 2 stops to cut the width of the joint on the stretchers. They limit the outer and inner extremity of the cut. And to move through this procedure, we can do one side, flip it, go to the other, and just keep it inside those bounds. And from there, we already have our outer extremities met, and we can just hog out the remaining material with multiple passes. These stops are set so our width of cut will be slightly more narrow than the rails, because we know we want them to be thinner than our rails so we can plane them down and fit them into our joint perfectly. It's not absolutely critical. You get the depth of cut to what it says in the dimension drawings. You do want to get it as close as possible. That said, once we've made this cut and we fit this rail in there perfectly, we can reference the depth of cut onto the rail and make our depth of cut on the rail accordingly so it fits in perfectly. I do like to do these cuts 2 pieces at a time, just so I know my cuts are in perfect alignment, and also it speeds up production a little bit. From here, the procedure gets a little more straightforward. We don't need to be as methodical. We're just gonna remove the remaining material with multiple passes. I'm gonna do one at a time as it doesn't require as much precision, and we've already got what we wanted by using 2. So now that the joinery is cut on the stretchers, we're going to plane down the rails so we can get a perfect fit into our cuts.
Before planing down my rails, I'm going to score off the ends of the longer piece and break it down into the 2 rails. The reason I break it down into 2 instead of sizing it all at once is in the off chance there's a variance in the widths of the dados on the stretchers I just made. The key to getting the rails to fit perfectly snug is to take as shallow passes as possible on your planer until you get a perfect fit. Do 1 rail at a time. Now that the rails fit snug into the dado, the depth of cut for the dado on the rails needs to be determined. To get a precise measurement, place your rail on the joint on the stretcher and mark out a line at the top of the stretcher. The material above this should be removed. This is how deep you need to make your cut to get a perfectly flush half-lap joint.
I'm gonna sneak up on the depth of cut, just doing multiple passes, raising the blade bit by bit until I reach my reference line. To get the width of cut, we're gonna use stops like we did before. That said, you're gonna have to go off marked lines that you had based off of your stretchers. You're gonna wanna keep them inside and then sneak up to the outer limits. I've got my 2 stops set up here to keep my work pieces within the bounds, to keep the blade within the bounds of the marked cut, which is referenced off of the stretchers.
Once you've made the initial passes of the left and right side of the joint, do a quick eyeball to see how the joint's fitting. A note on the use of stops: it's critical that you have an auxiliary stop on the fence and that for each pass on the outer extremities, your workpiece is tight against your stops. This is just a design detail I decided to do at the end. I'm cutting a 5-degree angle off each end of the rails. You can see you can get quality joinery just using a table saw and a planer. It's possible you may have to smooth out the bottoms of your joints with a chisel. Before jumping into your glue up, it's a good time to sand your components. Make sure you don't sand where the joints will be glued. The glue up is done in 2 stages. First, we're going to glue the legs. Do a dry fit of the stretchers and the rails first.
So for the glue up, we want even horizontal pressure on the bridle joints. And to do that, you're gonna have to make 4 shims that counteract the angle of the legs. And you can see here, I've glued 2 pieces on each side to make a channel to go outside of the bridle's tenon, and then put some tape on so it doesn't adhere to the glue.
Take your time at this stage and attach each of the shims with clamps and position them accurately. To get effective downward pressure across the rails, you'll have to make this simple platform with 2x4s and plywood. I recommend doubling up 3/4 inch plywood so it is as rigid as possible. Be methodical in applying your adhesive with a brush to all the joinery. It's a good idea to tape the outside of your joints to allow for less cleanup when it's dry. Because this is a complicated glue up, I use West System epoxy, which has a 1-hour open time, allowing me to take things nice and slow. Though your joint should be nice and snug, they may slip during assembly due to the lubrication. Have some more clamps ready to secure them in place. I will note for the final assembly, I didn't use these quick clamps on these joints. I used F-clamps and I made them really tight. This is where the clamping platform comes in handy. You can see how I'm using it to apply downward pressure on the rails with these F-clamps. The final clamps run horizontally and are positioned on the shims attached earlier. This is a challenging glue up, so be sure to have all the necessary clamps ready and available. Also make sure you orient your clamps so the successive clamps can be used correctly. It's best to do a dry fit or mock assembly without glue before jumping into the actual final glue up.
So as you can see, this was a pretty complicated glue up. You're definitely going to want to make sure you have the shims to counteract the angled legs, and be sure to tape them up so they don't stick to your piece. And yeah, I made this simple base. I think if I were to do anything differently, I would make this a little more substantial, or bring the 2x4s out to the side so it was a little more rigid. It's just bending a bit at the bottom. I use West System epoxy like this has a long open time, so it makes it a whole lot less stressful. That said, if you were to use Type-On number 3, that also has a reasonably long open time. So start with clamping each bridle joint so they stay in place. Get it upright, and then put the vertical clamps in, and put some pressure from the top to bottom, and then run the horizontal clamps. And then from there, you can kind of just tighten things up and add more secure clamps to the bridle joint to make sure everything's perfectly tight. Make sure your gaps are closed. You're doing an angle glue up, so sometimes the legs want to move out of place. Just make sure everything's nice and tight, and you'll be happy with the result.